Trebuchet is a type of catapult used by armies in the Middle Ages to attack castles and fortified buildings. The trebuchet is made up of a base, the tray, the counterweight, the throwing arm, the sling, and the finger. The sling has 2 ropes with a pouch in the middle. One rope is attached to the throwing arm, and the other has a ring on the end. To load the trebuchet, you have to pull the throwing arm down, secure it in place, put the projectile in the pouch, put the ring on the finger, and put the sling in the tray. To fire the trebuchet, release the throwing arm. It will swing up, pulling the swing with it. When the sling reaches a certain point, called the release point, the ring slides off the finger, the sling opens up, and the projectile is released. When I found out about trebuchets, I was interested in knowing if sling length would affect the distance that the projectile is thrown. Before we started building our trebuchet, my dad and I researched trebuchets on the internet. We found the following interesting facts about trebuchets. The angle at which the sling releases the projectile is dependent on the angle of the finger. The length of the long part of the throwing arm should be 3.75 times the length of the short part of the throwing arm. The starting position of the throwing arm should be 45 degrees with the vertical. The best length for the sling is equal to the length of the long part of the throwing arm. The mass of the counterweight should be 100 times the mass of the projectile. If it takes the same amount of time for a short sling and a long sling to reach the release point, then the projectile in a long sling would be moving faster when it is released. So I hypothesize that a longer sling would throw the projectile farther. To perform our experiment, we needed to build a trebuchet. First, we created a design using a program called FreeCAD. CAD stands for Computer Aided Design. We use the CAD design as a starting point for our trebuchet. The frame and the throwing arm of the trebuchet are made out of wood held together by bolts and screws. The counterweight is made out of iron weights that we bought at a second-hand store. It is fastened to the trebuchet by an iron bracket that we made ourselves. The sling is made out of rope held together by clamps, and the pouch is made out of an old pair of jeans. The finger is made out of a screw that we cut the head off of. To build the trebuchet, we had to use power saws, a power drill, some wrenches, and a screwdriver. And a measuring tape also. To perform our experiment, we used 3 sling lengths and fired 3 trial shots for each sling length. The projectile we used was 2 apples, and we measured the distance to the farthest apple after each shot. The 3 sling lengths that we used for our experiment were a 6-foot sling, a 5-foot sling, and a 4-foot sling. The farthest apple in the 6-foot sling went an average of 67.03 feet. The farthest apple from the 5-foot sling went an average of 85.3 feet. The farthest apple from the 4-foot sling went an average of 92.27 feet. Our conclusion is that the 4-foot sling launched the apple the farthest. From these results, I have concluded that my hypothesis that a longer sling would launch the projectile further was incorrect due to the fact that the shortest sling launched the projectile the furthest.
Test fire with really short sling number 2. Fire when ready. 1, 2, 3. Baboosh. Fire number 3 with super short sling. Ready? 1, 2, 3. Fire.